Hello and thanks for joining our presentation at the Configuration Workgroup Virtual Conference 2020. My name is Falk Brauer and I'm running the Manufacturing COE at InMindCloud. I'm happy to present today to you use cases and integration capabilities of our product Manufacturing X, always following customer scenarios that we run today. We will particularly look into application scenarios of variant configuration, but also look beyond into more engineer-to-order applications with CAD and map integration. But let's first take a little detour into the future. How will manufacturing companies sell in 2030? And then come back on what are the challenges today. So, will sales be driven by augmented reality and artificial intelligence? Will sales cycles be 10 times faster and only online? Will chatbots replace human sellers and spare parts be only sold proactively by IoT platforms? Or will sales still be driven by product catalogs and Excel? These are all relevant questions for 2030 and we will come back to this later. But are augmented realities, chatbots and artificial intelligence the key investment areas today to speed up sales cycles and increase win rates? Probably no. To better understand mission-critical capabilities of manufacturing sales, let's look into different sub-verticals of manufacturing companies that we serve today. The problem in digitizing the sales process in manufacturing today is that 70% process coverage is just not enough. We need to go the extra mile. In steel and metal and automotive supply, for instance, it is critical to integrate directly into the backend for accurate cost estimation and digitize the process of non-standard requests. This often requires on-system collaboration between different departments. Investments are made in this area to protect margins and accurately and timely answering special requests to increase win rates. For engineered solution, critical capabilities are end-to-end solution dimensioning with BOM calculation and visualization with the benefit to automate the sales and simplify partner business. For contract manufacturing, matching RFQs and capabilities as well as managing long-term costs and prices are among the top priorities. And for industrial machinery, equipment, high-tech and medical, speed and solution selling and accurate forecasts are critical to become more agile, to have early warnings and fill gaps in the production forecast. So what does InMindCloud do to help achieve those goals? We help customers to become faster and more agile and in general offer a fast time to value. Our cloud solution is called Manufacturing X, and as the name says, we are specialized on discrete manufacturing sales only. Because we are also specialized, our software has built-in best practices for manufacturing. And our solution is very much quote and product offer oriented, but embeds right within your CRM or commerce process. Many of you might know us from bringing SAP variant configuration from ERP into the cloud. Also with a tight integration into SAP Sales or Commerce Cloud. So let me first talk about this use cases, about how it works and what we add on top, and later explain some scenarios that go more into direction of solution dimensioning with CAD and maps integration. Let's start with a use case. So what does it need to sell a machine, for instance? Not only a single machine, but a whole solution that focuses on what the customer wants to achieve, because that is what we want to achieve, right? So your solution needs to support that. So first, and that is very important, is you do not want to sell a machine specification, you want to sell something that solves a customer problem. And your sales solution should do exactly this and not start with entering a specification. Second, the machines should fit together if you sell a solution. Very important. Third, Still, a machine will have a specification, but that should be as much as possible derived or inferred from the customer problem. So you don't want to talk specs to your customer, you want to talk solutioning. Last, machine does not stand alone. There are a lot of things which are built around it. It needs to be very easy to find those things, which are, for instance, accessories, consumables, spare parts. And the sales product knowledge needs to sit in your sales solution. Also a critical capability. So now we have seen a lot of slides. Maybe let's see how that looks within our solution. So that's the commercial view in the solution screen. Here in this example, we enter the specification from the customer for a whole production line. And here are the machines that are then selected. And we can also select software, complementary products, and so on. And we have them all in the sales bill of material, apply a discount, and we're actually ready with the whole solution. So this was our little example for direct sales and solutioning, maybe also useful for partners in very close relationships, and commerce scenarios would obviously look different. So what does this have to do with wiring configuration? First thing, we didn't go into the actual machine configuration here, the layout blocker, which could be straight coming out of ERP and leverage our integration with SAP solution configurator to run in the cloud. We didn't need to set values because this was directly inferred from the solution on top. So talking about wiring configuration, I need to say that user exits and the like sitting in ERP need a special treatment in the cloud, but we have done that in the past. But there's more. Often you want to adjust slightly what you have done in ERP. For this, we allow, for instance, to regroup or reorder your ERP characteristics in our solution. Sometimes you want or you need to build a sales configuration that is to some extent decoupled from your manufacturing-oriented ERP configuration. One example where this is, for instance, needed is when your ERP configuration does not have user exits, but your ERP configuration is actually one huge user exit. For such cases, it's actually possible to have two KMATs in ERP, the manufacturing-oriented one on the right, and one for sales running in the cloud here on the left. The historically grown manufacturing-oriented would be still needed in ERP to control, for instance, production planning and your production BOM. Both can be separated and a mapping can be established when need be. For instance, to trigger a cost run against the production KMAT in ERP for cost plus pricing, or of course the most common application to create an order. On top, that's more the application side showing now on the left, is that you could have different business processes that you need to cater for. One might be specialized applications in certain industries, and the other one are commodity applications, and both sales processes need to run on the same platform. So now I have talked a lot about applications and scenarios. Let's look a little bit under the hood and see how the integration with SAP ERP backends actually look like. So on top, there's the application layer, which is running in SAP HANA Cloud and integrates also in existing front-end solutions such as Sales or Commerce Cloud. The application layer talks via a platform layer to SAP Sales Solution Configurator in the cloud to read and execute the SAP configuration and pricing procedures. In addition, there are application-specific data which is replicated to the cloud. With this, we can fetch, for instance, account master, material variance, or material classification. In addition, arbitrary tables and views can be replicated from ERP to the cloud to achieve a certain functionality. Examples for such functionality are, for instance, material replacement or substitution to manage your product life cycle, material cost, or any other data to influence either the configuration, the pricing, or the general application behavior. The connection to ERP shown in the middle is actually established via SAP Cloud Connector. In a traditional configure price quote setting, there are many more things we should talk about, starting from regional product availability or constraints to stock levels, ATP check, delivery schedules, and so on. From a configuration point of view, a sales solution in manufacturing should also cater for slight modifications beyond the standard that is maintained in variant configuration. For this, we bring also features such as costing, material creation, so that you can run those workflows also in an end-to-end fashion. Starting from there, a whole new set of application areas opens up, which are more engineering driven. Let me talk about those next. So there are business models which are more project oriented or even go into costing for mass production in contract manufacturing settings. These application areas of manufacturing X you would rather name, for instance, design automation or cost simulation rather than CPQ. So let's look into that. So let's take a closer look at those two categories on the right and focus on the success criteria. So project-driven sales requires engineering knowledge built into the system, comprehensive dimensioning capabilities. Examples are, for instance, electrical, mechanical engineering or hydraulic calculations, so that you can find the right components from the customer requirements. From there, costs and prices need to be pulled and estimated. So usually the raw costs or prices come from ERP and you aggregate them based on your customer requirements. The cost estimation usually does not only include materials and components, but also estimated service efforts. The input for such project proposals often does come from distributed virtual teams, and those need to collaborate on a digital platform. So everybody needs to provide their piece to produce a winning proposal. This kind of requirements are, for instance, dominant in heavy machinery and electrical and mechanical engineering. Let's go to the box on the right, design and manufacturing as a service scenarios, where you look into very low-level details of the production process to estimate a price for a part which is produced in thousands, 10,000s or 100,000s. This kind of scenarios are dominant, for instance, for automotive suppliers, contract manufacturing, for instance, for rubber and plastic, packaging, but also for high-tech supplier industry. Advanced costing capabilities and collaboration are also key in those settings. For our customers in this space, our system turns into a production cost estimators where you configure and estimate the production process and not only the product. Cost aggregation and simulation, detailed price calculation, cost and price tracking of contracted components over years to support change orders are key success criteria here. So let's loop back from here to my introduction. I said 70% process coverage is just not enough for manufacturing industries. We need to go the extra mile. And every subvertical in the manufacturing industry has its own challenges, objectives, leverages different sales channels and needs, different capabilities to succeed in digital sales and commerce. Let me take you from here through a couple of our customer examples, their business benefits, process coverage, so you get a glimpse on what is possible today. Here's an example from the electrical engineering domain. Company which is selling switchboards for hospital and similar sized buildings. Objective of this company is to speed up sales cycles and to scale the sales force and eventually give this also to their partners. So this is not only a cost saver, it's completely changing the customer experience in terms of turnaround times and becomes really a competitive advantage in terms of interaction and service delivery. So on the slide, you see on top the process and below some screenshots of CAD files that are required and generated by our system. They contain an electrical and mechanical layout of the final product, which is needed in both the sales engagement and the final assembly and installation of the actual product. The drawings are generated from the bill of material and its structural relationships using breaker placement rules in our system. Again, here we follow the customer requirements, which is put into the electrical drawing. The logic to assemble the whole solution is then used to position the breakers physically out of semi-finished goods, including also sheet metal and copper bars and the like. And then the overall solution is composed and costed and priced and can be quoted and sold to the customer. So process-wise, beyond the account and pipeline management, we have here an engineer-to-order process, which requires design automation, following electrical and mechanical calculations and heuristics to assemble the bill of material, run a costing, including an estimation of assembly and wiring costs, and the visualization and proposal generation. Once ordered, whatever was prepared in the quote can go to ERP with our 5-click ERP material creation, including the entire material master, production bill of material, and the production process in terms of material routing. Here another use case more in the engineering automation space, hydraulics. This customer was looking to scale his partner business and is in the irrigation domain. He wanted to bring knowledge and speed to partners who are also residing in growth markets where engineering experience is more difficult to find. On the top we see again the process, and on the bottom are some screenshots from the solution. In this example, the user interacts directly with maps to get a topographic view of the system and can relate the solution components in a spatial relationship. Just by drawing the area of a field to be irrigated and selecting a few design criteria, the entire system, including pipes, pumps, and other systems, can be determined. And this includes also pressure calculations for each and every pipe in the system, which requires dimensioning to make sure that the pipes don't burst and you have the right pressure in every part of the system. Process-wise, this is somewhat similar to our previous example, just that it targets more distributors and value-added partners rather than internal sales staff. My last example is very different. While we previously talked about scenarios in solution selling, where a solution is maybe hundreds to millions in USD, we're talking now about sales of low to mid-value components which have a price range from some cents to maybe some hundreds of dollars. And the cost estimation is not for a single item, but it's more for thousands, 10,000s, or even hundreds of thousand items to be delivered. So very different ball game. So the concrete example that we are looking at is from automotive industry, so automotive supply. And the process usually starts here with a customer reaching out with a specification of a component to be produced, or a CAD drawing of the same with a request to provide a price for usually different minimum order quantities, which could be also staggered over time, like 100,000 this year, 200,000 next year. Usually this follows a kind of tender process, and an entire virtual team is working over days or weeks on the proposal. It starts again with the design, but design here means more the calculation of raw material requirements and costs, picking the right processes, machines and work center to manufacture the good, decide which sub-assemblies should be built in-house or subcontracted, and which plants would have the best capabilities and be most cost efficient. So our solution turns in this context to a process orchestrator that allows different personnel to capture manufacturing process elements, cost components for the overall solution, and at the end to simulate different assumptions against core KPIs such as margin or EBITDA. Once the tender is won, again, material creation helps to bring everything into the ERP backend and prepare for mass production. Then, as there's mostly a kind of framework contract, the offer process does not stop here. Requoting due to changes in amortization, technical changes, changes in the raw material prices, exchange rate or other factors is common practice. Actual costs need to be compared to the last cost estimates to give an indication on the range of price changes and the value of the changed KPIs. Depending on the kind of business, this would be a regular process repeating, say, every quarter, or a more heavy approach where tens or hundreds of price changes are negotiated every month. So how does that work from an architectural point of view in this case? Let me leave out here the integration to front-end systems, Autodesk Forge for CAD integration, and Google Maps for capturing topographic data, and just focus on the ERP integration part. Right? Here we would pull out the raw component and work center data from ERP and run the cost estimation outside using our calculation engine. On top comes a tracking of historical costs and prices. In the opposite direction, we create an ERP as usual, quotes and orders with some customization capabilities, and if need be, materials with BOM and routing, MRP, and so on. So let me summarize my presentation with a high-level overview. On top, we see front-end systems and other third-party tools with whom we can integrate in a standardized fashion. At the bottom, we see the core manufacturing systems, where we have also worked with other systems than ERP to achieve specific use cases. In the second row from the top, you see the modules of our application that can be composed to support different scenarios with varying complexity. Below, we want to highlight that we are not limited to that. For special requirements, our manufacturing X services can be consumed by third-party applications to really allow a 100% digitalized sales process. So, what was it all about? What are the advantages of manufacturing X? So, point one, a manufacturing sales solution needs to have 100% coverage with respect to the offering which may include configure to order processes, assemble to order, and engineer to order as well. Point 2. To have a 100% process coverage, you need to capture all business models, channels, and phases in your sales solution. Point 3. Different than in other industries, in manufacturing, data from your core manufacturing systems is key for all mission-critical activities, which more than anything includes also sales and distribution. Point 4. It needs to be very easy for the user to operate a sales solution. Just bringing the technical specification of your product to the front line does not help. Your offering should appear driven by customer requirements, and the translation of customer requirements to machine specifications should not be done by humans. It should be done by the sales system itself. Point 5. There's more. To make sales really efficient, there are many tools, and they need to be connected end to end. We bring a lot of standard integration, but we are also open at the same time. Thanks for joining today. My name is Falk Brauer and I'm heading the manufacturing COE at InMindCloud. Please feel free to reach out to me directly, or you may also contact Gabriele Villani, our solution expert in Germany, or Markus Scheurer, VP Sales. Last, let me also advertise our website. We have great material over there, starting from industry white papers over industry-specific webinars to success stories. You can also enjoy a free trial which contains a fancy autopilot mode that walks you through the industry examples, or you can just schedule an expert talk from there.